After a year of long waiting, Pandas 3.0 is finally here, and it's a major update. This isn't just a bug fix, it brings automatic string inference with PyArrow performance, copy on write as default, that eliminate the infamous setting with copy warning forever, a new and cleaner pd.col syntax, and improve datetime handling. If you are still on 2.x, here are the 5 key upgrades that make Pandas 3.0 worth switching today. For these tutorials, I will be using two Jupyter notebooks, one running on Pandas 2 and other running on Pandas 3, and walking through the practical examples to clearly demonstrate the upgrades and major enhancement. Start with installation. Simply type pip installed pandas 3. You can ignore this warning, it won't impact. The first one is dedicated string data type. For years, Pandas has used NumPy object data type for strings, which was slow and memory hungry because it could store any Python object. Starting with Pandas 3.0, string column automatically get the new string data type, backed by PyArrow for massive performance gain. Let's first check the Pandas version. Here it is 2.2.2. In Pandas 2, if you take string data series, then originally it is a object data type. You have to specifically mention data type as string, which is slow and memory hungry. But when you use this same code in Pandas 3, you don't have to mention the data type. The data type is now string instead of object, and this happened automatically. No code changes needed. And if you check the backend of this series data type, it will show PyArrow. Actually, it uses PyArrow for lightning fast operation, but PyArrow must be installed for this. You will see a great performance differences when you take very large data set. Let's take example of very large Pandas series. Now I am testing this code on Pandas 3, so I have to specifically mention the data type as object to replicate their data type, as default data type in Pandas 2 is object. And for this code chunk, I am not mentioning any data type. By default, it assigns string data type. When you run this code, you will see the new string data type is about 2 to 5x faster for string operation as compared to the Pandas 2. And if you consider the production code with millions of rows, this is very huge. Have you ever tried to run this chain assignment in Pandas 2? This code might work, might silently fail, or might show warning. It was impossible to predict. Even now, if you try to execute this code, you will get setting with copy warning. A value is trying to be set on copy. If you ever seen this setting with copy warning, well, good news, it's gone completely. Pandas 3.0 make copy on write the default and only mode. This means every operation that return a data frame or series behave like a copy. No more confusion about views versus copy, which means we get predictable and consistent behavior. And chain assignment now never work. Now if you want to do assignment in Pandas 3.0, you have to use single step assignment with dot lock operation. And here the value get updated. So there is only one rule. If you want to modify a data frame, you must modify it directly in a single step using dot lock or dot ilock operation. Let's take another example and understand how subset behavior work. Create a subset and also modify the subset. And when you print the original data frame, you will see nothing change. And when you print the subset, you will see only subset change and the original is never affected. Behind the scene, Pandas is smart. It uses views when possible and only copies when you actually modify the data. So technically, you will get predictability and performance in same go. Have you ever been frustrated writing these lambda functions just to reference a column? Then this changes is for you. Pandas 3.0 introduced a new syntax pd.column, a cleaner and more readable ways to work with a column. Inspired by PySpark and Polars, you just have to write pd.column, column name, and you are just referencing that column. Look how much cleaner that is. No more need of using lambda function just to reference a column everywhere. pd.column support method chaining like structure.upper, structure.title, etc. or any series method. You can use pd.column anywhere you would normally use a lambda, like in sign method or lock method or other similar methods. It is a small improvement, but it makes your code much cleaner and easier to read. Feature number 4 is datetime improvement. Earlier, Pandas defaulted to nanosecond resolution for datetimes, which limited the valid range to roughly around 1678 to through 2262. In Pandas 2, when you try to work with older date, it throws an error of out of bound datetime. In Pandas 3, the default is microsecond resolution, significantly expanding the supported date range and allow you to work with a much wider date range. But Pandas 3 work perfectly. You also notice here the data type is datetime 64 US, that is microsecond. Before it was nanosecond, which is limited the date range. Now you can work with historical date from the year 1000 or the future dates in the year 3000. Pandas now automatically pick the resolution based on your data. If you only have dates, it uses second. If you have millisecond, it uses that. And if it is a nanosecond, it uses nanosecond. Very smart and efficient. The last but not least, the Arrow C data interface. This is a major breakthrough for compatibility. It allows you to share data between Pandas, Polars, DuckDB, and other data frames libraries without copying memory, thanks to the Apache Arrow format. This is the Pandas data frame. You can simply convert to Arrow table. Just import PyArrow. Pass this data frame inside the from Pandas function from PyArrow table. If you print this, this is PyArrow table. This is done automatically with zero copy. You can even export Pandas data frame to Polars. First check whether Polars is installed or not. Type pip install Polars. Import Polars. Pass this Pandas data frame inside the from Pandas function of Polars. Print the Polars data frame. You can perform Polars operation like here we are using pl.columns. This is something we see earlier. pl.column is derived from the Polars. You can also convert Polars data frame back to the Pandas. Use toPandas function. With the arrow interface, you can easily move between Pandas and Polars without expensive data copies. Same for DuckDB, Arrow, and other modern data tools. This makes Pandas 3.0 play nicely in modern data ecosystem. Before we wrap up, here are the quick migration tips. First, upgrade to Pandas 2.3.3. which is the latest one, and fix all warnings before moving to 3.0. Second, Pandas 2.3 allow you to opt into behaviors that become default in Pandas 3, like if pd.option future influenced string equal true. In Pandas 3, string column will be default to new string data type, not object. This flag let you test that behavior now. Third is by enabling copy on write by default. This flag allow you to test that behavior in Pandas 2.3. After that, you can update any code checking for object data type. Instead of that, check for string data type. Replace the chain assignment with dot lock. Old one doesn't work. Also installed PyArrow for efficient performance. And lastly, test your code thoroughly. Once you are done with this step, you are ready to upgrade to Pandas 3.0. And that's the Pandas 3.0. This is the foundational release that makes Pandas faster, cleaner, and more predictable. Check the migration guide in the description and upgrade today. If this is helpful, drop a like and subscribe for more tutorials.